Hello and welcome to Lesson 4 of our factoring unit. Today we're going to look at 3 applications of the distributive law that will help us factor quadratics. Here are 3 special products, and if you learn to recognize them, they'll really help you factor quadratics. Let's look at the first one, x plus y squared. Let's actually do that multiplication. X plus y times x plus y, and if we distribute it out, you can see we get x squared plus xy plus xy plus y squared. Let's collect up like terms, so we get x squared plus 2xy plus y squared. Now that you've seen where it comes from, we're going to go in the opposite direction and factor it. Let's start with one like this, x squared plus 10x plus 25. If you can see, you have a perfect square both as your leading term and as your constant. Then you can check to see it follows the pattern x squared plus 2xy plus y squared. In this case, that would be x squared plus 2 times 5 times x plus 25. Since it follows this pattern, we know that x squared plus 10x plus 25, when factored, equals x plus 5 squared. Let's do a really tough one. 16m squared plus 8mn plus n squared. We've got a perfect square at both ends, so we just have to check to see if the center term follows the pattern. The center term should be 2 times 4m times n. In this case, that's exactly what it is, so we know that this factors and it becomes 4m plus n squared. Remember, you can check all of these, so let's check this one. We'll multiply out 4m plus n squared. 4m plus n times 4m plus n. If we distribute that out, we get 16m squared plus 4mn plus 4mn to give us plus 8mn plus n squared. We've got the same trinomial we started with, and so we know we've done it perfectly. Lots of practice with these is the only way to become proficient at factoring them. So ask your math teacher for lots of questions. The next 2 products have very similar patterns. We can see that x minus y squared equals x minus y times x minus y. If we distribute that out, we'll have x squared minus xy minus xy plus y squared. Let's collect up the like terms, and we have x squared minus 2xy plus y squared. Again, if we're faced with a quadratic trinomial with perfect squares at both ends like this, x squared minus 6x plus 9, we can look for this pattern. In this case, the center term will be negative 2 times 3 times x. Since it is, we can factor x squared minus 6x plus 9 into x minus 3 squared. We should always check our work, so let's try that. X minus 3 times x minus 3 is going to give us x squared minus 3x minus 3x to give us minus 6x plus 9. We have our original trinomial, so we've done a perfect job. Let's do another tough one. 16p squared minus 24p plus 9. We have perfect squares at both ends, so we can check if our center term is negative 2 times 4p times 3. It is, so we can factor this. 16p squared minus 24p plus 9 becomes 4p minus 3 squared. Our third special product looks like this. If we distribute this out, you can see we get x squared plus xy minus xy minus y squared. And because these two terms cancel each other out and equal 0, we're left with x squared minus y squared. That's a very recognizable pattern. It's called a difference of squares because you have one perfect square minus another perfect square. Let's factor a few of those. Here we have the difference of two perfect squares. All we have to do is square root the two of them, 5p and 4, and then write our two binomials like this, 5p minus 4, 5p plus 4. As always, we can check. Let's check. Let's distribute it out. We get 25p squared plus 20p minus 20p minus 16. These two terms equal 0, so we're left with 25p squared minus 16. And we know we've done it right. Let's do another. You can pause the video, see if you can do this one on your own. I'll do it right now. We've got the difference of two perfect squares. Let's square root the two of them. 2x minus 6 times 2x plus 6. We could check by multiplying those out to see we got our original binomial. But with this one, there's an added wrinkle. We could have factored the 4 out to start with. If we did that, we would have 4 times x squared minus 9. Now it's a little easier to factor that difference of squares. We'd have 4 times x minus 3 times x plus 3. Let's try another one like that. See if you can do this one on your own. We've got two perfect squares, so let's square root them. 4x minus 3m, and then 4x plus 3m. Again, we can check by distributing it out. Let's. We get 16x squared plus 12xm minus 12xm minus 9m squared. Collect like terms, and we're left with 16x squared minus 9m squared. Now let's try a really tough one. You can see we've got a difference of perfect squares there. So let's square root them like this. X minus 1 minus x plus 1 times x minus 1 plus x plus 1. Now this can be simplified even further. Just be very careful to distribute out that negative. X minus 1 minus x minus 1 times x minus 1 plus x plus 1. And you can see that will give us negative 2 times 2x, and that's going to equal negative 4x. All right, those are our 3 special products to factor. Here's a few to try on your own, and the answers are on the notes sheet.